Okay, so hello and welcome to this video tutorial for A-level mechanics. So we have this problem from the June 2023 paper here. It's an early problem in the paper, so the earlier problems in the paper tend to be the easier ones. So in relative terms, this question is quite easy. Um, let's get let's go ahead and solve it then. So it states a particle P has a mass of 5 kilos. The particle is pulled along a rough horizontal plane by a horizontal force of magnitude 28 newtons. The only resistance to motion is a frictional force of magnitude F newtons, as shown in figure 1. Find the magnitude of the normal reaction of the plane on P. So first of all, what do we mean by a normal reaction? Well, a normal force or a normal reaction is what we might use to describe a force that is kind of preventing an object maybe falling through a surface or something like this. So in this context, the normal force is kind of the force that is acting up and preventing the ball from accelerating through the floor. And the normal force counters the weight of the object here. We can know the weight of the object because its mass is given. It's 5 kilos, so we can describe the weight here as 5g. I trust that you guys understand what I mean by 5g here. So naturally, the normal force acting here is going to be 5g as well. This is our free body diagram here. It's basically complete. The question's asking find the magnitude of the normal reaction. Well, we've just said it's 5g. Let's describe it in terms of a number. So we can say this is equal to 5 times 9.8, which is equal to 49 newtons. Okay, so that's our answer to part A. Part B, it says the particle is accelerating along the plane at 1.4 meters per second squared. Find the value of F. So this is where we can introduce this idea here, which I trust that most of you are familiar with as well, where we can say that the sum of the forces acting on an object is equal to the mass of that object times its acceleration. So in this context, the particle is accelerating 1.4 meters per second to the right. So therefore, we could say 28 minus F, since that's the sum of the forces acting horizontally on our particle here. You've got 28 acting to the right, F moving to the left. 28 minus F is equal to 5 times 1.4, so since that's our acceleration here. Okay. When I rearrange this, note that 5 times 1.4 gives 7, so I can say, therefore, F, if I add that to both sides and subtract the 5 times 1.4 from both sides, that lands me on 28 minus 7. There we go, which is equal to 21 newtons. Okay, and then part C says find the value of mu, giving your answer to two significant figures, where mu here is the coefficient of friction between P and the plane. So this is where we can introduce this idea. If you weren't aware already, the frictional force acting on an object can be taken as the coefficient of friction, which we typically describe with mu, multiplied by the normal force acting on that object. So in this case, we understand that the normal force acting on the object here is 49 newtons. And we understand from part B that the frictional force acting on the object, or force F, is 21 newtons. So we can basically just fill in this formula. Essentially, we can say that 21 is equal to mu times the normal force here, which is 49. Therefore, mu is equal to 21 over 49, which gives 3/7, which gives 0.43 as a decimal. Okay, so that's how I'd approach this problem. If you have any questions or comments, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.